All right, so today we want to move on to the next type of mole conversions. So here's what we've looked at so far. So we talked last week that our repeating topic theme in chemistry is the counting unit called the mole. And we talked about the fact that the mole is a connector, and one unit it connects to is the particle. And we talked about at this point, the only type of matter we've focused on are elements. And so elements have the smallest unit called the atom. And we looked at the relationship that involves Avogadro's number. So 1 mole is equal to 6.022 times 10 to the 23rd atoms. Okay, so the next one that we want to look at what the mole connects to is the mole can connect to the mass. Okay. Now, mass is the quantity, and the unit for mass we're going to be talking about is grams. Okay. So this has a relationship called the molar mass. So I'm going to tie in our activity from yesterday. So yesterday when you did your activity, you found how many grams there were in a mole. And this is the molar mass. And what we should have recognized is that the grams that you calculated in your table, this number comes from the periodic table. So the periodic table has an average mass that's displayed in the box. We've talked that that's calculated by using the average, a weighted average of the isotopes, and that we can call that the average atomic mass, which has units of atomic mass units. But now we know that number is also known as the molar mass, and we're going to use that value to convert between grams and moles in this section. All right, so we have a couple of problems to look at. So before we look at them, you're going to need a couple of things. One, a periodic table, and two, you're going to need a calculator. So if you need to pause the video so that you can gather materials together, you may do so. And then when you're ready, you can resume the video. All right, so here's problem number 1. What is the mass in grams of 3.6 moles of the element carbon? And so we've looked at a conversion factor that is a relationship between grams and moles. So that means that we are going to use dimensional analysis to solve our problem. When I look at the problem, we're looking for the given. The given has a number and a unit. And that's what goes first in my dimensional analysis. So I'm going to put my 3.6 moles of carbon in my opening box. Okay. Again, at some point we're going to be converting between one substance and another. So not only do I label it with the mole unit, which remember that MOL is the abbreviation for moles, but I'm also labeling it with the substance. And then underneath that, you can leave the box blank or you can put a 1 here. It's simply just a placeholder. In dimensional analysis, we're going to use units to set up our problem. So I need my moles of carbon to cancel, so we're going to put those on the bottom. And then what I'm wanting to find is the grams of carbon. So that's going to go up here on the top. Okay, so molar mass is defined as the number of grams in 1 mole. So 1 is going to always go in front of mole. And the number we're going to put in front of grams is the value from the periodic table. Now, you want to be using the periodic table that I've given you because that has rounded atomic mass on it, the rounded average atomic mass that we're going to be using throughout the year. Right? So carbon is number 6 on the periodic table. And if you look at the box, the molar mass is 12.01. All right, so since everything on the bottom here is a 1, we're going to multiply the numbers on the top together. And then I'm going to record an answer that has been rounded to correct significant figures. So we are going to look at both numbers that you're multiplying together, and you're going with the fewest total sig figs. So 3.6 has the fewest, it only has 2. So my answer is going to have 2. I'm going to label this as 43. And then my moles of carbon units would cancel. This would give me grams of carbon as my final answer. So that's our problem number 1. All right, let's look at my problem number 2. So it asked me to find the moles of copper that are in 3.22 grams of copper. So my 3.22 grams of copper is going to be my given. Now, just as a reminder from our earlier discussion, we're going to think of moles as a base unit. So if moles appears in the question, then that tells me we only have one conversion factor. So I have my dimensional set up, so we have just one conversion factor. I'm going to put my given over 1, or you can leave that box blank. The choice is yours. We want grams of copper to cancel, so that's going to go on the bottom here. And we're looking for the moles of copper, so that's what's going to go on the top here. Now again, this conversion is always going to be here whenever you're converting between grams and moles. The molar mass, and molar mass is defined as the number of grams in 1 mole. So the number from the periodic table is what's going to go in front of grams. And copper is number 29 on the periodic table, and it has a molar mass of 63.55 grams in a mole. Okay, so in this problem, we're going to multiply across the top, and we're going to multiply across the bottom, and then we're going to divide. And again, we're going to look at the two numbers we're dividing to determine sig figs. So that 3.22 has the fewest, it only has 3. So my answer is going to have 3 sig figs. And I'm going to give my answer in normal notation. So in normal notation, these are leading zeros. And just as a reminder, leading zeros are never significant. So the 5 is my first sig fig. The 0 here is my second. And then we're going to round the next place value to a 7. Okay. This 0 here would be captive, so that's why it's significant. So that's my answer rounded to 3 sig figs. My grams of copper are going to cancel and give me moles of copper as my unit. And so there's my final answer. Okay, so in review, Our conversion factor today was molar mass. So think of it this way. If I have a dozen eggs and a dozen elephants, my eggs and elephants, there's 12 of each because they were both a dozen, but they don't have the same mass. It works the exact same way for elements. So I can have a mole of copper or I could have a mole of carbon, and I would have the same number of atoms. So that would be Avogadro's number. But the mass between those are not going to be the same. Carbon's mass for a mole is 12.01, and carbon's mass for a mole is 63.55. Okay, so this ends our second set of mole conversion problems. So I have one more set of conversion problems to show early next week, and then we're going to have some Zoom office hours next week where you can ask some questions if you have them.